for this particular video, I'm going to treat it slightly different. I'm not going to walk through every single problem on the peer leading activity number 1, but I'm going to talk about some important points from each of the questions, as well as common mistakes and things that you should watch out for on the exam. And so for question 1 of your peer leading activity, if you have it in front of you, it was the question where you had to complete the blanks of the chart. And so you had the particles, you had the atomic number, you had the number of protons, number of electrons, number of neutrons, and the mass number. This is a very straightforward question, and no, you're not going to have a question directly like that on your exam, but it's important to know what each of those topics mean. And so atomic number, on your periodic table, it's the large bolded number that is above the element. And so when you're looking at your periodic table, the atomic number is what categorizes each of the elements. So no element on the periodic table has the same atomic number. And so for example, hydrogen has an atomic number of 1. And what does the atomic number mean? This is important because you're going to get a lot of questions that just give you the atomic number and want you to figure out what that element is. So the atomic number tells you the number of protons. If you change the number of protons, you're going to change the atomic number. If you change the atomic number, you're going to change the element. The atomic number is the number of protons. Now, what is our mass number? Our mass number tells us number of protons plus number of neutrons. So do not confuse these. Atomic number, number of protons, mass number, protons and neutrons. Electrons, their mass is negligible. So you can treat electrons as not having a mass. Our protons and our neutrons, they have a mass and they're stored within the nucleus. Now, the reason why I'm talking about these simple concepts is because I'm getting ready to show you a common mistake that students make. So let's take these two formats. When you're looking at the way that these notations are written, it's important to be able to identify which one is the mass number, which one is the atomic number. And so these are two of the most common ways that you'll see notation of chemical symbols written. So this first one, you need to be able to understand that 38 is the atomic number and 90 is the mass number. The mass number will always be on the top and the atomic number on the bottom. And so it's slightly intuitive to see that, okay, 90 is the larger number and that has 2 components, so that's probably the mass number, not the atomic number. But a lot of students do make this mistake of, hey, okay, this has an atomic number of 90, and that's not correct. This is our mass number, this is our atomic number. When it's written like this, it can be confusing because now there's not 2 numbers, there's just 1 number. So you don't know, is it the atomic number or is the mass number, okay? If you get confused, all you have to do is try to find the atomic number of 130 on the periodic table, and does it line up with that element? If it does not, then it has to be the mass number. But when it's written like this, the atomic number has been omitted, and they're just writing the mass number. So these are the 2 most common notations. Mass number on top, atomic number on the bottom, omitted the atomic number, and just have the mass number. So these are things that you should remember for the exam. One last thing, electrons. To determine the number of electrons that an element has, you need to ask yourself, is it neutral or is it charged? If it's neutral, it has the same number of protons. If it is neutral, it has the same number of protons. For example, this example that we talked about recently, this is neutral. So it has 38 protons, it's also going to have 38 electrons. But if we take an example that is charged, let's say Cu2+. We know that there's an imbalance between the protons and electrons. And so this tells us, because it's positive, that we have more protons. Because again, protons are positive and electrons are negative. So this tells us that we have 2 more protons as compared to electrons. So that is how you're going to figure out the characteristics and the components that make up particles. Okay, let's talk about characterizing compounds and elements. This can be a very tricky topic because of the terminology that is used here. So we have atomic element, molecular compound, and ionic compound. So first, let's distinguish between element and compound. This is pretty straightforward for individuals, but element, you can think about it as singular, okay, or the same. And so we're talking about multiple of one thing or just one thing. Compound is comprised of 2 separate things, where an element is just one thing. So singular versus plural. Now let's talk about molecular and ionic and atomic. The word atomic element is the easiest one to identify because this is just straight off the periodic table. You're pulling it directly off the periodic table. So don't get confused. Atomic element, pull it straight off. Pull it off the periodic table. Okay, so this would be just something like hydrogen, sodium, potassium. These are all atomic elements. Now, molecular versus ionic. This is very important to understand. For something to be characterized as ionic, it needs 2 things. It needs a metal and a non-metal. A metal can be found all the way on the left side of the periodic table, all the way to your metalloids, right before your metalloids. Then everything to the far right is considered a non-metal. So we need a metal, which is usually plus charge, and a non-metal, which is negatively charged, and that forms ionic compound. And so let's focus on that. Ionic compound is a metal plus a non-metal, right? These are plus charged, and these are minus charged. Okay, so an example of that would be, let's see, sodium chloride. Okay. We have our metal and our non-metal. So molecular then is kind of the opposite of ionic. Instead of having a metal and a non-metal, a molecular compound or element is going to be a non-metal, okay? If it's a compound, it's going to be non-metal, non-metal. If it's an element, it's just non-metal. And so this is a molecular compound. And so a non-metal, and it's an element. And so, again, from the periodic table, but there's more than one. So an example of this would be phosphorus, P4, okay? Phosphorus is straight from the periodic table, but there isn't just one, there's multiple, and that's what separates it from atomic element. Molecular compound is a non-metal plus a non-metal. So a non-metal plus a non-metal, okay? An example of that would be carbon dioxide. Carbon is a non-metal, oxygen is a non-metal. So that would be a molecular compound, okay? Again, element is singular or the same, so singular or 4 of the same thing. Molecular compound, non-metal, non-metal. Ionic compound, metal and non-metal. Okay? Now, really quickly, I've just pulled 2 examples from question 5 on the peer leading worksheet number 1. And the reason I've done that is because I want to pull out some pain points that you should remember, but also some common mistakes that students will make. Naming is also a very common exam question, and also labeling a compound as ionic or molecular. So, we have N2O, okay? Is that ionic or is it molecular? So again, we just talked about it. Ionic is a non-metal and a metal, where molecular is 2 non-metals. So we have nitrogen and oxygen. Those are both 2 non-metals. And so that will tell us that this N2O is a molecular compound. Now, why did they ask us to characterize it as ionic or molecular before naming? It's because, depending on whether the compound is ionic or molecular, it's going to change the rules or the parameters in which you will name that compound. So, when you are naming molecular compounds, you are going to use the numeric system. So you're going to use di, tri, mono, things like that. So, we have 2 nitrogen and 1 oxygen. I see a lot of students put nitrous oxide, but remember, this is a very systematic way of naming. We have 2 nitrogen, so that's going to be di-nitrogen. And we have 1 oxygen, so that's going to be monoxide. So we have di and mono, okay? So you're going to use the numeric prefix when you're naming molecular compounds. Now, something to remember. You only omit mono if it's characterizing the first element. So if this nitrogen had been 1 and not 2, you don't need to say mononitrogen monooxide. You would just say nitrogen monoxide. Okay? But here we have 2 of them, so it's dinitrogen monoxide. So you only omit mono if it's characterizing the first element. Next, we have barium phosphate. And so we have barium, which is a non-metal, and we have phosphate, which is a polyatomic ion. If you have a polyatomic ion in your compound, it is always ionic. And for ionic compounds, you're going to name the metal ion, which is barium, the first. And then you're going to name the polyatomic ion, which is phosphate. If this had been something else, right, an element off the periodic table, you're going to end that compound in this suffix, IDE. Okay? So that is how you name for molecular and ionic. If it contains a polyatomic ion, just write ionic. Make sure that you take the name straight off the polyatomic ion chart that you guys were given. Please memorize that. You're going to name the metal cation, and then you're going to name the polyatomic ion or the non-metal off the periodic table and change the ending to IDE. This is a very common exam question, so make sure you understand this. The last thing I'm going to discuss is how to use your calculator in this class. I know this sounds weird because we all know how to use a calculator, but I find that there's a lot of students who know exactly what to do. They know how to solve the problem, they understand the concept, but they still end up getting the question wrong because they didn't type it into the calculator correctly. And so I just took a few examples off of the peer leading activity number 1 that we're going to quickly discuss. So this first question, you have 3 times 10 to the 8th divided by 5.2 times 10 to the negative 9th. Okay. It's very important when you're typing scientific notation into your calculator that you put parentheses around the scientific notation so that it can solve for that, and then it will divide. So you want it to solve this scientific notation, then you want it to solve this scientific notation, and then it can divide. And so when you plug that into your calculator, right, you want to make sure that you include those parentheses, because if you don't, you're going to get this number here. And it may seem correct. You may be like, okay, good, perfect, all is well. And you may even see that answer choice on the exam. But the truth is, that is incorrect, because when you put parentheses around this number, and then divide them, you get 5.76 times 10 to the 16th. And if you know anything about dividing numbers that have exponents, you know that you're going to subtract the exponent. So it's 8 minus negative 9, which turns 9 to a positive number. So 8 plus 9 should give you 5.76 times 10 to the 16th. Okay? So make sure that you put parentheses around scientific notation, or you're going to get the question incorrect. Same thing here, but this is a little bit more complex. And I'm going to show you what I did to ensure that I always was confident in the answer that I received from the calculator. So again, like before, please put parentheses around scientific notation. And then when you have a number being multiplied by another fraction, or by a fraction in general, put the fraction in parentheses, and then again, put parentheses just around the scientific notation number, right? If this number had also been scientific notation, you would also put parentheses there, but there's no need to put parentheses there, okay? If that's too confusing, solve for this number, write it down, divide this fraction out, and just put the parentheses around our scientific notation, figure out what that is, and then multiply those numbers together, and you'll get an answer. But if you want to put this straight into a calculator, put parentheses around this, put parentheses around the function of division, and then around the scientific notation number, and that will ensure that you're going to always get the correct answer. If you feel more comfortable treating it as parts instead of typing the whole thing into your calculator, do that as well. So that's how to use a calculator. Please use parentheses. It's going to save your life, trust me. And that is all I have for the peer leading activity number 1. If you have any further questions, if you're in my peer leading group, just send the message in the group me. But for this first activity, I just wanted to give you an overview of common issues and things that you should know for your upcoming exam. Thank you.